All right, let's talk about the IB Maths internal assessment. I know, it can feel like this huge, intimidating mountain you have to climb. But what if I told you it's actually a game, a strategic challenge that, if you know the rules and have the right playbook, you can totally crush? So let's dive in and crack this code together. First things first, why is this so important? Well, that number says it all. The IA isn't some little side project. It is a massive 20% of your final IB Maths grade. Just think about that for a second. This single project could literally be the difference between grade boundaries. So yeah, it's absolutely crucial we get this right. So here's our game plan for today. We're going to start by defining your mission. Then we'll lay out the blueprint for building a solid IA. After that, we'll decode exactly how it's graded, figure out how to score every last point, and wrap up with some final pro tips you won't want to miss. Let's get into it. Okay, section 1, your IB Maths mission. Because look, before you even think about writing a single equation, you have to know what the whole point of this thing actually is. What's the goal? So what is the IA, really? At its core, it's your personal investigation, somewhere between 12 and 20 pages long. And you've got two main paths to choose from. You can either prove how a piece of math works in the real world, or you can take two variables you're curious about and model how they relate to each other. The best part? It's your chance to explore something that actually interests you. Now that we know the mission, we need a blueprint, right? Every great project has a solid structure, and your IA is no different. You can't just wing it. Every single great IA is built on these 5 core components. You've got your introduction, background, the main calculations, a conclusion, and of course the bibliography. Honestly, the best way to think about these is like the 5 acts of your own mathematical story. Your introduction is where you set the stage. You got to grab your reader's attention right away. Tell them why you chose this topic. What's your personal connection? Then briefly explain why it's important. And this is the big one, state a crystal clear aim. What question exactly are you trying to answer? Next up is the background section. This part is all about clarity. You can't assume your reader knows everything. If you're using any special terms, define them. If you're using some fancy math that's beyond the syllabus, you've got to explain it. And if you're using data, you have to say exactly where you got it from. And spoiler alert, it has to be from an official, credible source. Now we get to the heart of it all, the main calculations. And listen to me on this. This is so important. You need to show everything. And I mean everything, even your mistakes and wrong turns. Why? Because explaining how you found an error and then fixed it, that shows real learning. That's the good stuff. And finally, we bring it all home. Your conclusion needs to be a sharp summary that directly answers the question you asked way back in your introduction. And the bibliography? It's pretty straightforward, but you can't mess it up. Just list every single source you used and keep the formatting consistent, like APA or MLA style. Okay, so we've built the structure of our IA. Now let's flip the script and think like an examiner. To really win this game, you have to understand exactly how they're going to score you. So where do these 20 marks actually come from? Take a look at this. Use of mathematics is the biggest slice of the pie. Yeah, it's 6 marks. But what might surprise you is that presentation and mathematical communication are worth a whopping 4 marks each. The takeaway here is huge. How you write and present your work is almost as important as the math itself. All right, so the big question, how do we squeeze every single point out of this thing? Let's break down each criterion one by one, and I'll show you exactly what the examiners are looking for to give you top marks. First up, criterion A, presentation. Now, this is not about using fancy fonts or colors. It's all about structure and clarity. Is your paper well organized? Is there a logical flow? Is it easy for someone to follow your train of thought? That's what scores you the points here. Now, check this out. Look at the jump from 3 marks to 4. Getting a 3 is about being coherent and well organized. Pretty standard. But to get that top mark, you need one more secret ingredient. You have to be concise. That means no fluff, no repeating yourself. Every word, every graph, every equation has a purpose. Okay, criterion B, mathematical communication. This is all about speaking the language of math correctly. Are you defining your variables? Are your graphs and tables labeled properly? Are you using the right notation? It's all about being precise. Again, look at the difference between a 3 and a 4. For 3 marks, your communication is mostly consistent. But to get all 4, it has to be consistent throughout. See that word? That's the key. It means from page 1 to the very end, your notation, your definitions, everything is perfect and consistent. Now let's talk about two criteria that students always get confused: personal engagement and reflection. A great way to think about them is as two sides of the same coin. Engagement is all about your forward-looking, creative process, while reflection is you looking back with a critical eye. So to make it super clear, personal engagement is where you show off your own curiosity and creativity. You explain your personal journey. Reflection, on the other hand, is where you step back and analyze that journey. You ask, so what? You connect your results back to your aim and think about the strengths and weaknesses of what you did. You need both to score well. And now for the heavyweight champion of the criteria, use of mathematics. This is the big one, worth a massive 6 marks. This is where the quality, the correctness, and the sophistication of your actual math gets put under the microscope. Now, you really have to know if you're SL or HL here because the expectations are totally different. For standard level, your math just needs to be relevant and mostly correct. A few small errors are okay, but for higher level, oh, the bar is way, way higher. Your math has to be precise, sophisticated, and every single claim you make needs to be justified or proven. We've got the blueprint, and we've decoded the grading. To wrap things up, let's do a quick lightning round of final pro tips to make sure you avoid those common pitfalls and turn in an IA that really shines. All right, let's run through these winning reminders. 1. Show your mistakes. It proves you're actually learning. 2. Use official sources only. Seriously, no Wikipedia. 3. Label everything. I mean every graph, table, and axis. 4. Be coherent. Make sure all the parts of your IA logically connect to each other. And 5, if you have huge tables of data, stick them in an appendix to keep your main paper clean and concise. So let's reframe this whole thing. The internal assessment, it's not just another task to check off a list. It is a genuine, rare opportunity to think and work like a real mathematician, to ask your own questions and find your own answers. So the only real question left is this: what will you discover?